similar polygons answers. Number 9. There we go. Okay, what else from the homework, guys? 12. All right, starting with number 9. Okay. Triangle ABC is similar to triangle A prime, B prime, C prime. The scale factor is 7 to 9. If the perimeter of ABC is 45, then the perimeter of A prime, B prime, C prime is blank. Okay. The problem here is, well, let's set up a proportion. So in our proportion, we have the perimeter of triangle ABC, and then the perimeter of triangle A prime, B prime, C prime. The scale factor is 7 to 9. So that's second over first. Remember how a million times I told you scale factor is second over first, scale factor second over first, scale factor second over first. Okay, so that means that our second one, the prime, is 7, and then the first one is 9. So 7 goes with the prime, A prime, B prime, C prime, and 9 goes with just ABC. So when you cross multiply, 45 times 7 divided by 9, you get that the perimeter is 35. We don't have any units, so we don't need to worry about putting units. Now we're looking at number 12 from the homework. We have the perimeter of a rectangle is 60 centimeters. The ratio of the base to the altitude is 5 to 7. Find the lengths of the base and the altitude. Okay, so step 1, please do me a favor and draw a rectangle. The perimeter is 60. The ratio of the base to the altitude is 5 to 7. Base to altitude. Altitude is another word for height. So if you were kind of tripped up by which one the altitude is, it's like a base and a height, okay? So the ratio of the altitude, base to the altitude is 5 to 7. 5x to 7x. Remember, when you hear that word ratio, you're attaching a variable to each one of those numbers because they're not saying that the base is 5 and the height is 7. That's not what they're saying. So now we're just going to set up a really easy equation. 5x plus 7x. But remember, when you're finding the perimeter of a rectangle, which we'll officially study later, but you've already learned it, the perimeter of a rectangle is you double each of the sides and add them together. And we want to come up with 60. So 2 times the base plus 2 times the altitude equals the perimeter, because there's 2 of the 5x's and there's 2 of the 7x's. All right? 10x plus 14x equals 60. We okay with that now? I'm glad. Okay. Divide by 24. X is 2.5. We need to find the base and the altitude, so 5 times 2.5 is 12.5. And 7 times 2.5 is 17.5. You know you can always do math enter, and get the fraction form instead, depending on what the problem on a quiz or test says. Okay, are we good with 12? Okay, last one is number 14. We know when we see a proportion like that, we're going to cross multiply. That is how you solve proportions when you're missing a variable. So we're going to do 3 times 12 equals, and I'm going to write out the step that I normally don't write out. I'm going to actually show my work for once. 3x equals, this one's tricky because people are tempted to say that that is 12x, but that is not 12x because 2 times 6 is 12, and x times x is x squared. And then minus 6x. This is a factoring problem. It's officially a factoring problem. So we're going to set it equal to 0 like we always do in factoring problems. And then please, 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 before you start factoring, pull out the GCF, pull out that greatest common factor because it's going to make your life easier. I see a 6 in all of those. So 0 equals, I'm going to pull a 6 out, 2x squared minus x minus 6. Are y'all with me? If you had your cameras on, you could shake your head, but you don't have your cameras on. Yes, you're with me? Okay. So we actually don't care about the 6 anymore. Yes, it's still there, but no, it doesn't affect our answer. So now we need to think of things that multiply to get 6. We get to double one of those. We get to double one of those, and we need to come up with a -1 somehow. We know that this is going to be 2x and x. We just need to find out which ones we're going to use. If I double 2, if that's our winner, if I double 2, I get 4. I can make a -1 out of a 4 and a 3. I want to make sure my 2 gets doubled, so I'm going to put it where it's going to definitely get doubled when I FOIL. And then I'll put his partner, 2 and 3, partners in crime, right there. I want it to be a -1. So I want that 4 to be negative, and I want that 3 to be positive. Negative, positive. Now we set them both equal to 0 separately. When you solve this one, you get x equals 2. When you solve this one, you subtract 3 from both sides. That's where the -3 halves comes from. When you're factoring and you have a leading coefficient, one of your answers is always going to be a fraction, by the way. Okay? All right, let's go over something before we dive into today's lesson. Make sure we really have a grasp on what similar means. So, I'm going to show something, an action that we're going to do to quadrilateral ABCD, and you're going to tell me if the action produces a figure that's similar or not similar to the original. So if you agree that it's similar, put agree on your status, and if you disagree, if it's not similar, then put disagree in your status, okay? Just a reminder, before we start this, 2 figures are similar, because this is huge. 2 figures are similar if their angles are congruent and their sides are those are the 2 things that have to be true. That is what similar is. Angles congruent, sides proportional. Angles congruent, sides proportional. That has to be committed to your memory, okay? So that's what makes 2 figures, 2 polygons similar. All right. So we're going to take that quadrilateral ABCD, and we are going to divide each x coordinate by 2. So agree if what you come up with is similar, and disagree if you think it is not similar. Okay, I have lots of disagrees. Who would like to share with me why you disagree, why what we come up with is not similar to the original? Ganesh, go for it. Do you want to talk with your mic? Very good job, Ganesh. You can't just divide the x coordinates by 2. Every coordinate has an x and a y. If you want to remain proportional, you would have to divide the x by 2 and divide the y by 2. Awesome answer. Let's keep going. We translate ABCD down 5 units. Agree or disagree? So remembering from last unit, translate means slide. All I'm going to do is slide my figure. Now, what kind of figure am I going to get? What's going to be the relationship of what I get? Congruent. Very good. Now, here's a big question. Are congruent figures similar figures? If 2 polygons are congruent, are they also similar? Sure. So they have the same relationship as isosceles triangles and equilateral triangles. Are all equilateral triangles isosceles? Yes, they are. Are all isosceles triangles equilateral? No, they're not. Similar and congruent have the same relationship. Everything that's congruent is similar. Not everything that's similar is congruent. So this one was false. This one is true. What you get is similar to what you started with. If they are congruent, they are also similar. It's harder to be congruent than it is to be similar. So if you're congruent, you're definitely similar. Similar is like a prerequisite to being congruent. Next one, multiply both coordinates of A by 3. Agree or disagree? They're not similar. Someone type in why they're not similar. Yeah, you can't just affect one of the points. You can't just multiply both of the coordinates of that one by 3. I agree you have to multiply both of the coordinates, the x and the y, but you would have to do it to all of the vertices, not just one vertice. Very good. Okay, a couple more. Let's just go through these quickly. Rotate ABCD 90 degrees clockwise. Rotate it 90 degrees clockwise. We're going to get a congruent figure. And we already said congruent figures are similar figures. So check. Last one. Multiply all of the coordinates by 1/3. That is called a dilation. And dilations always produce similar figures. Okay? So there we go. Let's move on. Today's topic, title your notes, similar triangles. On Friday, we talked about similar polygons, but that could be any polygon. Yeah, Illuminati. Anyways, today we're going to zoom in and we're going to focus only on triangles, on proving triangles guilty of being similar. Does that sound familiar? Last semester, we proved triangles guilty of being congruent. This time we're going to prove them guilty of being similar. What were the congruence postulates? Do you remember? Side, 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 angle, 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 side, hypotenuse, leg. There were 5 of them. 5 of them last semester. CPCTC was not one of the postulates, but it was one of the things on our proof sheet. You're right. So the good news about this is that number 1, you've already learned how to do this, and number 2, there's going to be less similarity postulates than there were congruence postulates, okay? So why do I have a picture of the back of a dollar bill on here? I'm just trying to show, I know this is 3D, and we're talking 2D, but I was just trying to show that this triangle is similar to this triangle. You have similar triangles on the back of your currency. All right. Very nice. All right. Here you go. I'm handing you 2 triangles. I want to know if they're similar. No. What would we need to check? What would you go about doing? The angles. Okay, let's check the angles. What do you think? Uh-oh. Nope, that angle doesn't check out. Oh no, that angle doesn't check out. So even though, to me, I mean, those look similar to me, but if the angles are congruent, then call all your bets off. They're not similar if the angles are not congruent. Good, proportional sides, we need to check the angles are congruent. We would need to check that the sides are proportional. What? Okay, so I'll just give it away. There are 3 ways that we're going to prove triangles guilty of being similar. There's the 3 ways. You probably know what they stand for. Angle, angle, similarity. Side, 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 similarity. And side, angle, side, similarity. Now, the big thing here, remember that squiggly means similar. If on a quiz, if you just write side, 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 and you don't put the squiggly after it, I'm going to assume that you're telling me that those triangles are congruent. And I bet on the quiz they're not going to be congruent. I bet they're just similar. So make sure you communicate to me that you know that they're similar and not congruent by putting that squiggly. That squiggly is imperative. It is part of the postulate, okay? Very important. Did you write these down? There's 3 of them. You want me to call it a tilde instead of a squiggly? Squiggly is so much more fun to say. Let's talk about each one at a time. Why is this one called angle, angle, similarity instead of angle, angle, angle? Because last time I checked, triangles had 3 angles. How do you type the squiggly? It's above the tab. You see above the tab? Shift and then the thing above the tab. Below the escape. Next to the 1. Yes. Okay, no one's answering my question. Why is this called angle squiggly when triangles have 3 angles? Because if 2 similar, the third is similar. Remember, whoa, careful. The angles are not similar. The angles are congruent. Just be careful. The angles are equal. Yeah, there's this universal rule in Euclidean geometry, not in spherical geometry, be careful. In Euclidean geometry, there's a universal rule that, hey, the angles of a triangle, any triangle add up to 180. So if you know 2 angles of a triangle, boom, you know the third angle. So you only have to check 2 of the angles. We want to be efficient all the time, every time. We never want to do too much work. Okay. So, angle similarity. Check that 2 angles match and you're done. I'm going to move on. The next one is called side similarity. I am not saying that 3 sides have to be congruent. We know that they're not going to be congruent. We want the 3 sides to be proportional. Keyword proportional. So you need to set up ratios. Set the ratios equal and make sure they're equal to say that 2 triangles are guilty of being similar. Angles congruent, sides proportional. Do you think that we have to check all 3 sides? What do you think, guys? Is there a universal rule out there that says, oh, the sides of a triangle always add up to blank? No. There's no rule out there that says all the sides add up to this magic number like the angles do. So unlike the angles, yes, you have to check all 3 sides. So you can either check 2 of the angles or you can check 3 of the sides. It just depends on what you're given. Can I move on? So we're going to say 2 is to 4 as 4 is to 8 as 3 is to 6. Since all of these reduce to 1/2, then we know our sides are proportional. No, like, do they have to give you all the sides? Yes, they would have to give you all the sides or give you a way to find the missing sides if you don't have all the sides. For this postulate, at least. Now, let's say that I took my figure and I rotated it a little bit and you don't know which sides go together. I didn't even label these. You don't even know which sides are corresponding. When nothing is labeled and you don't know which sides go together, you can always put the largest over the largest, the medium over the medium, and the small over the small. So you find the smallest one and the smallest one. 3 is to 1 as, find the medium one and then the medium one. 15 is to 5 as largest, largest. So make sure that you don't just start pairing numbers together that don't go together. Small goes with small and large goes with large. Then you reduce all of them. This reduces to 3, reduces to 3, reduces to 3. So, yep, those triangles are similar. The last one that we can use is called side similarity, where you have 2 proportional sides and you have the angle in between. Make sure you add arcs to your picture if you're drawing this in your notes. Can it be any old angle? No, it cannot be any old angle. The angle has to be sandwiched between the sides. If it's a different angle of the triangle, then they're not guilty of being similar. We don't have enough information. Okay, determine if the triangles are similar. So, at first glance, hopefully you're seeing that these look like there may be side angle side. Kind of looks like it. I have 2 sides and I have the included angle. But we know that the 70s are equal, so that's good news. Check. Now we need to compare the sides. Smallest over smallest and largest over largest. Okay? So here's the smallest side and the smallest side. 6 is to 10 as 9 is to 15. And you need to see if that's true or not. Are those proportional or not? Yes? They both reduce to 3/5, right? Very good. Since they both reduce to 3/5, we can say, yep, these are similar, and they're similar by side, angle, side similarity. Side, angle, side similarity. Determine if the triangles are similar. I'm going to let you try this one. Do you have to check all three sides? You absolutely have to check all three sides. Yep. Small, small. Medium, medium. Large, large. And definitely not true. Were any of them equal? Yep, the first two were. This was equal and that one was not equal. So, do you have to check all three? Yes, you have to check all three. Determine if the triangles are similar. We would write NS for not similar. Yep, the first two were proportional. The third one was not proportional to the first two. Oh no, we don't have any numbers here. So we're comparing this triangle, kind of like the dollar bill, to this triangle. And we're trying to see if they're similar. Side, angle, side, you already got it. Okay, well, they definitely share this angle. Boom, we've got that angle. Then if you have trouble with when you have symbols but no numbers, you could totally make up numbers. Like you could call this 2, 2, and you could call this 3 and 3 since they have tick marks. Then you could say, you could compare them, okay, 2 is to, what's the whole thing, 4, as 3 is to the whole triangle 6. Do you see how I just made up numbers so I could test this to make sure they're proportional? And obviously it's 1/2 and 1/2, obviously. Guys, don't talk about that in the real chat. Go to the presenter chat for that. So anyways, we get 1/2 both times. So you're right, this one is side, angle, side, similarity. Good job. The tick marks are our sides, and then the shared angle is that angle. Determine if the triangles are similar. There are 3 triangles here, so let's just talk about 2 of them. Let's just talk about the one on the left and the one on the right. Let's not talk about the large triangle. So we know this is true, right? But now we need to make sure those sides are proportional. Okay, so good, Chloe. So if this is going to be any of them, it's going to be side, angle, side. But we don't know if it's side, angle, side yet. So we actually do have to do the work. We have to set up a proportion. So I'm going to look at this one. I'm going to look at the green one. What is the smallest side of the green one? Well, it's 9. Now I'm going to look at triangle number 1. What's the smallest side of triangle number 1? Well, it's 3. Now go to the green one again. What's the largest side? 27. What's the largest side of triangle 1? It's 9. And guess what? 9 divided by 3 is 3. 27 divided by 9 is 3. Those are equal. So these are guilty of being similar by side, angle, side, similarity. Okay? So that one was tricky. That shared side was the smallest side of one triangle and the largest side of the other triangle. Solve for x and y. The directions just changed. We're not proving them similar. We're solving for x and y. Are these 2 triangles similar? Are they? Because you surely can't set up a proportion unless they're similar. And I would say, yes, they're similar by angle, angle. Because this is a shared angle. And then the other two with the double arc, those are corresponding angles with parallel lines. So, yep, they're similar. Now we can set up a proportion. We want to be careful here. We want to be comparing the small triangle to the whole triangle. So if I said 12 is to x as 15 is to, what would I put there? 12 is to x as 15 is to, don't you dare say 6. Okay, good. You need to add up the whole side. So 12 is to x as 15 is to 21. Don't use 6 because 6 is not a side of a triangle. It's a partial side. We don't use partials. Okay? 12 times 21 divided by 15. Did you get 16.8? Yep. Okay. Next one. 15 is to 21 as 10 is to 5. 15 is to 21 as 10 is to y. As 10 is to y. 10 is the base of the small triangle, and y is the base of the whole triangle. We've got small over whole, and we've got small over whole. So when we cross multiply that, we get 14. Y is 14. All right, that's it. Have a great day, guys.